Welcome to Misunderstanding Cloud Native. Hope you'll enjoy this session. We're going to make it a little bit interactive together with you because we would like to hear from you as well. What do you understand about some cloud native concepts as well? And just to introduce ourselves, I am Anna. I'm a developer advocate for Red Hat. Very interested in building cloud native applications. And together with me today is my dear friend Rustam.
Hello, everyone. My name is Rustam. Thank you for the introduction. We'll be doing this talk together. I am based in Norway, Oslo. I'm working in a consultancy company called Kubernetes. So I'm a Java champion together as Anna, and also I'm a Cloud GD, so Google Developer Expert as well. So today, we want to talk to you about cloud-native applications and how people tend to misunderstand that. But before we do that, and since it's kind of getting late in the daytime and everything, let's do a system check. Up with your hand. Good. OK, now we know they're working. We want you to use those hands during the talk or towards the end of the talk and ask questions and comment about things and everything. So we'll be using that thing. So now we checked it worked. So now we can actually start. All right. One more thing before we actually get it rolling. The short universal answer to all the things that we will be talking about is something that a lot of us have said, and something a lot of us don't want to hear. So usually the answer is, it depends. It depends on a lot of things, and this is what we'll be trying to talk to you about as well. A little bit longer and a bit more serious version of that is this, right? So everything you do comes with qualitative and quantitative pros and cons. So there will be something positive, possibly something negative, but you have to always measure which one is which. Right. Since we're talking about cloud native, it's a good idea to do a quick definition of what cloud native actually is. So this wall of text over there is a definition copy-paste from CNCF Foundation, so Cloud Native Computing Foundation that has this definition. But you're not supposed to show wall of text on the slides, on the presentation. So we kind of tried to help you a little bit with that. We highlighted some words. We tried to help you a little bit more. We removed all the other words. And now you kind of see the gist of what we're trying to do. To make it a bit more easier to digest and comprehend, we decided to also split it in 3 categories. It's what we're trying to build, how we want to build that, and why do we want that? I mean, why on earth do we want to do all that things that we're going to tell you about, or all those things with containers and service meshes and microservices and all that? I mean, it's cool and all, but why do you want to do that? Well, it's because you can create loosely coupled applications. They will be resilient. They will be manageable, observable, with robust automation, and all those things, so on and so on and so on. And also, when you kind of try to convince someone about something or trying to tell and explain something new, you should probably start. This is this little circle thingies on the corner there. So you start with why, and then you go with how, and then you actually explain what you want to do. So this is what we're going to try to do. All right. First misunderstanding, kind of the most common and most well misused, I guess, or misunderstood. Over to you, Anna.
So, is cloud native meaning that we should always deploy apps to the cloud? Well, this is actually coming from the part that people believe that the cloud equals public cloud. So, if you're looking back to the CNCF definition, the cloud is actually the place where you can deploy your scalable applications, and it can be public, private, or hybrid cloud. So it doesn't have to be necessarily public so that you can go cloud native. You're not limited to that. Furthermore, if we're talking about scalable applications and about clouds, again, we have 3 different clouds, also coming from CNCF definition, but to bring more context to that and to make sure that everybody has a clear understanding of which is which. First of all, the cloud typically can be public or private. And there are multi-clouds. Well, you're building scalable applications on clouds that come from different providers, and typically those are public when you're thinking about multi-cloud. And there's hybrid cloud, which is involving cloud, public offering, and at least one on-premise version of that cloud, which is typically private and so on. So hybrid is like a mixture of those, and you need at least one on-premise. Just try to not forget that one. Furthermore, maybe some of you are like wondering, when do I need these kind of things? How do I choose between those? And that's a valid question. So this is just one idea on how to decide for your cloud offering. So like, have a cloud offering that matches your workload. So you have a decision based on the amount of resources that you might consume. When you're choosing a provider or an offering, you kind of make some math before that. So you're like thinking, okay, what do I know about things that I want to build? And sometimes, if you don't know how your workload is going to oscillate in time, how it's going to behave in time, you don't know how much our end users are going to come to your platform and use from that, then you go for a public offering, because that one can provision for you instances on without you to care like, okay, do I need to preoccupy myself with this or not? If you can't predict the resources needed for your application, then going private is a good option. That one, and of course, some security constraints, or maybe you already had a data center and you want to reuse that one. So in that case, go for private. And last but not least, if you can partially predict what you want to do, hybrid clouds can help you and are the best solution to host workloads anywhere. So try to think of that, but this is just one idea of choosing a cloud version. A decision based on amount of resources. There are many, many more things that you should take care of and think about when you're choosing one of the offerings. And we can talk about those at the end.
We should probably mention that sometimes that decision will be made for you. So sometimes the customer or a client or something, whoever that might be, they will say, we want to do one way or another. Sometimes legislation will force you to do hybrid cloud because you're not allowed to move some of the data because of reasons, privacy, whatever that might be.
Yeah, many times I've experienced that.
Oh yeah.
Took the decision for me already. So, those being said, now let me talk about clouds. We want to engage a little bit, that we verified also that the hands are working. So, vendor lock-in. Can you please raise your hand if you are afraid about vendor lock-in?
Or have heard this as an argument, we cannot do X because that will lock us in. Yeah, well, we have a few hands. That's good. All
right, we're going to talk with the rest as well. So lock-in is a risk, of course, but there's a risk in every software decision that we're doing. When we're taking some decision, maybe it doesn't look obvious to us, but yeah, at some point in time, it's gonna look that, we should reassess that decision. And speaking about reassessing that decision, Rustam, what do you think about vendor lock-in? Can you expand a little bit more on that one?
I can try. So when vendor lock-in is a funny thing, because like I said in the beginning, anything you choose might lead to some kind of vendor lock-in. If you choose a library, if you choose a framework, if you choose a platform, if you choose a language, a programming language, you will at some point end up with some kind of lock-in. But the thing is, now you have to weigh in pros and cons and see which of those cups, if you put it on the weights, which of those two cups will be heavier. And then you have to think about things. At some point, you will also be put in front of a problem, or you will have to take a decision whether you choose a product A or product B. May that be on cloud or on Prem or whatever. And then you have to think, is that product A, is it open standards, open source platform kind of thing that everybody knows and probably several vendors might support? Or this is a super specific for that particular platform, cloud, whatever, that you go in there, you will have to rewrite everything if you have to move it. Again, this is not that one of them is good, the other one is bad. It is actually, the thing is that it will depend. If you don't think, the chances are that you will be forced to move, and it gives you a lot of extra things like, I don't know, portability, or not portability, but
building it quicker, because
exactly.
one decision when thinking of a piece of software produced by someone is like how urgent it is for you to build that thing. Waiting for something to be available as open source or as, I don't know, coming from another vendor, it might not be viable in the world that we're living in.
It might cost you advantage, right?
Actually, it's, the applications that we are all building as developers, they serve a purpose, and waiting until something gets available, it's not something feasible in the current economy. It's better to be daring and build something that is going to be fixing those requirements, adjusting to those requirements, and actually delivering revenue and so on for those requirements. And of course, later on, maybe preoccupy ourselves about portability and so on. This doesn't mean that we should build something quickly just for the sake of it and pray afterwards it works. It's just about documenting well what made us take that decision, and also like come back to those cons that we had at some point in time and reassess how we can adjust and migrate what we did to a better, to even better solution.
And also, I mean, it can be put in one way, like running things yourself versus managed services. That's one way of looking at that. But then managed services can be open source solution that's managed by someone or proprietary solution that's managed by someone. So then you have to kind of map your needs and what you will get out of it, and then think which one is best. So, Anna, back to you. Lift and shift versus further development. Based on your experience, what should you do? How do you do that?
So yeah, we talked about choosing vendor, clouds, vendors, and so on. Now let's talk about approaches on building stuff, right? So what about lift and shift versus further development? When modernizing something, thinking about going native, cloud native, there are several options. One misunderstanding has been happening for some time in the industry is that when you're containerizing an app, this means you modernize it. Doesn't matter what you put in there, you modernize it because it runs in a container, and that's great. Well, if you're thinking back to the definition that was saying that it was in the beginning from CNCF, it was talking about scalable apps, it was talking about having automation and a lot of loosely coupled services and so on. So maybe what you're containerizing is not agreeing to that definition. Okay, we can say we don't care about the definition. Let's just containerize it and be happy. Well, at the end, the cost of containerizing something might not make you happy. So, one approach of modernizing is lifting and shifting, which pretty much means rehosting something. But that one is minimally modernizing what you were doing before. It doesn't make, let's say, a significant miracle to what you were doing before, but is a good first step in modernizing your stack. Secondly, you can modernize this and just lifting and shifting and give more time, like a buffer time until you actually have time to refactor the application later, so like you gain some traction around that. How do we do lifting and shifting? So that's another important aspect. Because lifting and shifting has a few steps, and this is our opinion about lifting and shifting, by the way. So how do you do that? First of all, you analyze the source code or existing artifacts. You look at what you already have, what you're planning to do with it, right? Then you're planning and you're estimating your work. There are tools, by the way, that can help you in giving you migration paths. That's a very good thing to use. The tool might not give you the perfect migration path, but you can then, as a human being, together with your team, get together and improve on that migration path. That's the purpose of using the tool, like to actually do some work for you, and then you just improve minimally and so on. Then after you identify the migration issues and evaluate the solutions and so on, and everybody agrees that's okay, then you can containerize the existing application components while you're keeping the data and integration parties on the legacy. So it's not like a totally disruption from the legacy side. And typically you are deploying this on a platform as a service. That's how you would typically see it in the nature of clouds, as deployed on a PaaS. So that's, also there are some companies that have described their experiences with lift and shift And they pretty much all due to these steps that we have identified here.
So basically, when when you do want to migrate, you lift and shift just to do least effort thing, move it over to the cloud, forget about all your on-prem stuff. If you want to do that, if you want to go that way, right? You forget about all that, let it run on the cloud, and then you do kind of strangler pattern, remove piece by piece, and create more cloud-native applications out of it.
But even better, further development. You can sometimes boost with new layers what you are having on legacy. So build APIs or interfaces that can give a boost to your already existing applications and improve what you're already doing. So that's another intermediary step. And of course, the last one is the complete rewrite that's to happen when we are re-implementing everything, and we believe that everything is going to be happy and nice and jolly. But one thing that I want to draw attention to you is like complete rewrite means rethinking how the platform is architected. So first of all, you look in the past. You don't get away from that one. You still have to look in the past, how it was architected, developed, so that you don't do the same mistakes, even though that you're going with a different architecture now. And then re-implement it using the cloud-native technology and all the nice features. So not just rewrite and without looking to the past, you have to learn from the past mistakes to build something better. And well, talking about better, well, a lot of people have said that better go serverless. And Rustam, what do you think? Is it better to go serverless?
Well, again, it depends, but that's the answer nobody wants to hear. But look, how many of you have heard this thing like, oh, we're going to try this serverless thing. I mean, just because, for no reason, we don't have everybody talks about this thing, we're going to do that. I see quite a few hands, kind of probably roughly half-ish of the people sitting here. So that's a kind of a good sign of a misunderstanding, because now we're not trying to bash serverless. Serverless is a good thing. We're trying to bash this whole misunderstanding concept of like, this kind of sucks a bit. All right, so what is serverless? Serverless is a kind of weird name, right? We probably have learned that already, but it probably should have been called manageless, but it's not as beautiful to sounding word. But the idea is you do not have to, or you have to do less management of the service. Somebody else, a system, is managing things for you rather, right? Well, there is a definition, right? Serverless is a cloud-native development model that allows developers to build and run applications without having to manage servers. To some extent, right? It's not 100% manageless, but it's much less. Another thing that people usually think is that, well, if I want to go serverless, if we decided that serverless is the way to go, and that's like the next step would be like, oh, to go serverless, we need to put it on a specific cloud. And again, that is not true, right? So you can put it on any cloud. Most of the cloud providers would have some kind of serverless offering. Those serverless offerings might be different. They might be a whole container managed, just tiny pieces of your code, like functions managed, or it can be something in between. Another thing people usually say and ask is like, do I really have to run it at all on a cloud to actually call it serverless? And again, the answer is no. Because serverless can be run on-prem. There are tools to do that on-prem that, again, sometimes you do not have the possibility to move to the cloud because, again, privacy, because of maybe you're using some very special hardware. Maybe you're using like super fancy GPUs or TPUs or something that are only available on your machines at on-prem. Then you cannot just move your stuff. But you can actually still benefit from the serverless thing where your applications will be scaling up and down and being used in a way that you actually free resources to be used by other applications that are more in demand right now than the other one. And then you scale up and down those resources. Examples are quite a lot of different examples. So there is the example of Knative, which is a open source Kubernetes-based, Istio-based. So there is like Kubernetes, Istio, and on top of that you have Knative that does all the management for you. There is, well, we can mention Quarkus Funky, which is more like, you know, a little bit different approach to that, but also a very, very interesting thing to look at. And then you can look at, instead of putting, because most of those things would be containers, right? But then you can also do small pieces of your code. But then you have to think one last thing when we talk about serverless, and we especially talk about serverless functions. That means, again, small pieces of code as a separate endpoint, as a separate thing. You need to think about how do you manage those. If you create hundreds and hundreds of them, you will end up being a cat herder, right? You will need to kind of make sure that all of them are running, all of them are happy, all of them are still being used, and all this. You might not want to do it so micro service level. You might want to go a little step up or something. So think about that as well. All right. There are ways to always to evolve your implementation, right? You have some options. You can it doesn't really matter. Well, in this case, we're talking about serverless, but it doesn't have to be serverless for most of those things that we're going to mention here. Kubernetes as well, and all this infrastructure, do not build it by hand. Write something that can build it for you, because you will be forced to build it over and over again, to create new environments, to create and tear down test environments, to create new production environment because your old environment, something went wrong, servers burned down, I don't know what happened, anything. You'll need to recreate that. Keep that thing updated and keep that thing as a recipe so you can actually press a button, go grab a coffee, come back, and your environment is up and running. That's kind of the dream scenario. Your mileage might vary. Of course.
So the solutions that we listed here, one of them, Terraform, is like when you're trying to re-platform some functions that maybe you wrote for a specific provider. Maybe you use Lambdas and you'd like to move to a different provider that doesn't have Lambdas built in. Terraform is offering nice solutions in that direction. The other way around is like that to take care about portability. Is using Knative. We have Kubernetes available, so these solutions are for portability point of view, because at some point in time, a lot of people ask themselves, but if I don't have that available, what do I do? How do I move that? And for many cases, when you're trying to reuse some code across teams, it would be good, but they probably have a different platform running under it. It would be worth to look at these options as well when it comes to migrating and evolving. So it's not a lock-in as much as if you're like taking care of using these kind of tools to completely re-platform things. Next.
Yes, I'll do this quick as well. So cloud is good, serverless is good. We're running everything on somewhere in the magical sphere of the cloud. But the thing is, like, we developers don't want to wait for it to be uploaded and deployed and all these things. You would like to try and test things locally first, or like one of the options is to simulate a local environment and pretend it is. And then actually, when you're ready and you're happy, then you actually put it on on-prem serverless solution or cloud or something. So there are different ways of that. Most of those providers would give you some kind of CLI or SDK, so you can develop things through the command line and do that, to run things locally, to pretend it is cloud, pretend it is on-prem serverless solution or something like that. But there is also things like OpenShift Sandbox that will pretend that it is a local environment and do you all those things, but it will be run somewhere for you and managed for you, which is also a nice thing. So this is more about the happiness of us as developers to be able to develop as fast as possible without waiting too much and waiting for things to be uploaded and deployed. And also when it comes to debugging, because debugging is much easier to do on your machine than somewhere else, right? All right, so another kind of big misunderstanding is that people often think that well, Kubernetes is the meaning of life and everything. And to do that, we need to create our own cluster, run it yourself, and run everything on my three tiny little apps. I'll put them all on Kubernetes, and I'll be like super modern, super cloud native and everything. What is your take on that?
So this is kind of a misunderstanding. It was ignited in the beginning when Kubernetes appeared because it looked like easier to learn. It's easy to learn, still easy to learn. Then if you're using Minikube, you can be tempted like, look, it's easy to manage. But Minikube is actually an enhanced or master that allows you to deploy stuff on it. So it's just one node there, it's a little bit mutant. So don't be tricked by that and thinking that Kubernetes platform by itself is similar to your Minikube that probably you have on your logo. When you're thinking of doing yourself a Kubernetes platform, so I'm talking here about the entire platform, not doing some deployment somewhere when somebody provisioned for you some infrastructure. You have to always think about this lovely picture with a lot of nice icons. That for each cluster, you need to use some deployment tools like kubeadmin or kubespray to provision the cluster, first of all. Then you have to configure it for high availability backup and think about restoring AD/CD. Why high availability? Because if your control plane is failing, you need another control plane to take over, like you make sure that your cluster is still available and alive. So you have to look into the high availability offering of deploying Kubernetes, not the easiest one available in the to-dos and how to do it. Then you have to manage certificates and secrets. So again, there's another concern coming on with that one. Not that easy. And then configure external download servers because for the API server, because probably you would like to access your loads from the external that specific cluster. And my favorite, where I am like always taking a long time thinking, is managing network policies with ingress and egress. So all this is just for one cluster, and make a highly available cluster. And now, if you're thinking like how many clusters you need for your entire platform, I assume that you would feel discouraged to do such a thing, unless you have a very big team of colleagues that really want to do it from scratch and want to maintain this on the long term. The idea is like not doing it once, we're doing it and maintaining it. So with every version of Kubernetes that's coming up, you have to look at the specifications of what changed. You have to look how you're going to upgrade that, how you're going to upgrade the cluster itself, the control plane and everything, how you're going to look and upgrade your deployments, your persistent volumes and everything else that you're running on top of what you do yourself. So overall, the story of this, although it looks like some actions there and so on, if the question is, should you do it? And you look again to the CNCF definition that speaks about automation, well, it might a little discourage you because then you have to automate these things. And you have to do it in a way that's predictable, while of course with minimal frustration for colleagues and for end users. So all in all, please wait if it's really worth it doing it yourself.
And well, one more thing is that one thing is doing yourself or getting someone to do it for you. That's one thing. The other thing, is it really worth it? Do you really need 3 nodes or 5 nodes that can take over containers and everything while you still have a tiny little app with 3 users a day or something, or like, I don't know, even 100 users a day? Is it really worth it? I mean, could you just put it on some kind of serverless solution instead and let it just be there and scale up and down depending on what you need? So that's the other side of that story as well.
True. So always weigh your options. Now, some people believe that if you're putting things in Kubernetes, you're instantly modernizing it, and we talked about this.
Anyone? Any hands? Anyone have heard that? No. Well.
Cool. So, the thing is that if you're modernizing an application, you should start with the application itself and afterwards think about the infrastructure. Like, take it step by step. Don't think that just because you are changing the infrastructure is going to magically produce something for you. And Speaking about magic, we seem to believe that continuous integration, continuous deployment, there has been some magic around it for some years, and there are still folks that believe that this can be like scripted once and works under any condition. So I remember the times when we thought that maybe we can envision everything that's going to go automatically with all the policies and everything for something that we didn't write yet, but we can script the pipelines ahead of time, and magically it's going to arrive. So, Rustam, what do you think about this? Do you think that we can script it once and then it works no matter what we're going to change to our apps?
Well, we can try. If you manage to do that, please give me a call. I would like to talk to you, and I would like to hear your experiences. And my experience is that that never happens. So the thing is, there are two sides of it. So one side is that, well, we wrote it once, and it's going to behave like that forever. And that's not the case, right? Things change, new versions come in and go. You have to change some kind of configurations and things like that. Another thing of that is that you should create, instead of, well, we talked a little bit about that already, right? It's basically UI point and click versus scripting it and creating a proper pipeline. Yes, clicking and pointing might be tempting because you're just going to do it once, but then when you have to do it again for second or third or fifth time, you will be hating yourself for doing that. You kind of really want to do that as a script and just make sure it is reproducible. The other thing is that it should develop organically. It should evolve organically. So that means that keep and stick onto your script, no matter how bad the timing is, and no matter how much things are burning on the production, and you really need to deploy that app, and you can just jump over a few steps, just do it manually to deploy it, and because something is burning. Try not to do that. Try kind of keep away from that temptation, because if you make sure that your script will evolve organically, it will be easier next time and the next time and the next time, and well, hopefully you will not have things burning down in production anyway. There are a few ways of doing that. There are a few ideas and thoughts what can contribute to create this good environment, to create resilient pipelines. So one of them is that to promote, and I've been doing the same kind of error. I've been in this project where things developed in the opposite direction, but what I'm trying to tell you, because we've done and didn't work, and many of us probably have done, is that it's not just one person who does the CI/CD pipeline and the other ones just look at him and throw things at him when things go red on a big screen somewhere. It's a shared responsibility. So everybody is in a little bit of DevOps and all that kind of a way of thinking as well. So everybody shares that responsibility. Like I said, pipeline evolves with your features, new features and new processes and new things that your software is doing. Merge to main as soon as possible. Do not have a bunch of timelines. I call them timelines, but it's basically branches in your Git running, because we've all seen the sci-fi movies. We know how things go when timelines go crazy and then they merge. Yeah, well, the same happens with Git, right? So don't do that. Merge as often as possible, keep it neat as possible, and run automated. So create automated tests in all levels, run them as often as possible, and all those things. And, well, frequent deployments, of course, and not once a year or 4 times a year, but rather as soon as something is ready. It doesn't have to go all the way automatically. It can be like one last step that will be manual to say, OK, go, or something. It does not mean that everything has to go automatically. It does not have to be, because sometimes you don't want to do that for that to happen. But, think about that and build for that. Another thing that we would like to talk a little bit about is observability. So it's the same kind of the idea, like I said, with CI/CD pipelines. You should use those CI/CD pipelines in all of your environments, starting from development environment, going all the way to production, preferably the same script, preferably the same way. And I guess a lot of those arguments for doing that and why it's good to do that, and basically you will see things much earlier. You don't see it only when it comes to production. and it starts burning there. You'll see it burning before, you'll fix it, and when it comes to production, it will be fine. So a lot of those arguments can be also used about observability and this misunderstanding of observability after reaching production.
Yes, because we should observe how things are working when they're live with our end users. Why not observe them before? The benefits of observing how your applications behave ahead of production is that you can identify some memory leaks or some problems under high load by using load testing, for example, before actually everything being live and being hit by, I don't know, thousands to millions of users, and having a lot of people disappointed that they cannot use something, and then you start patching and going under stress and everything. However, many folks think about observing what happens to their app once they reach production, because in that time it really burns and you're really interested in making it better. So to make a system observable, you can use instrumentation methods, including open source tools such as OpenTelemetry. OpenTelemetry is a specification that incorporates a lot of the tools, a lot of the practices that we can use nowadays so that we can observe our systems better. It's a collection of not just specification, it's also about tools that are okay. And we need to pay attention to the tools, because at some point in time, if one of the tools is not going to be on the market anymore, we want to be able to migrate our good work and, of course, the history that we have with that and so on, to another one. And tools that adhere to these kind of standards are really good to have and work with, so that we don't end up, rewriting everything and then thinking how we're going to keep that history in sync with the next one. Next about the observability is about collecting things. So we collect logs, we collect metrics. We collect logs because we need to look in those, and they're helpful when we're debugging stuff. We collect metrics because we want to know how good we coded things and how good our infrastructure is set up and so on. We look at traces so that we would know where our distributed transaction went through, so that we know where every request went through, and we know where we can improve our code, where is a bottleneck, where things are not behaving as expected, so that we can, offer a response to a user request as soon as possible. And last but not least, user feedback. This one is not in the developer tool. It's not in the tool set. It's said sometimes, like, how do you get user feedback? Do you send them surveys? Well, you can send them surveys if they're really liking what they're interacting with when they're using the application. But you can see user feedback having analytics tools within your apps. And with those analytics tools, you can see the engagement with certain features. Those are particularly useful to identify from which browsers, for example, your application gets invoked more, so that you can think about how you're serving and you're making your traffic to serve those requests. Secondly, those kind of analytics can give you an idea on the impact that some features of your platform are having over the users. Like if you see that there's a drop in certain areas, then maybe you need to improve some experience over there as well.
And then, then you can build on top of that. Then you can do like feature toggling, where you turn on and off features and see how things behave. You can also do blue-green deployments that you probably have seen on the most of the social media networks or any other apps or websites and everything, where you get one UI and your friend gets a different UI, and then they see how they behave, they log things, and then they decide which worked and which didn't. So you can build on top of that, and you can create more and more advanced and fun things to do. And
yeah. Well, I think the last topic I want to touch today is like almost zero downtime and scale to zero. We call it obsession, but it's more something that we wanted as developers for a long time. I mean, even when we were using application servers, we were always preoccupied for people not to feel that there was something stop at some point, and they were not able to use their application. So at that time, how we used to handle it as engineers, we were like having multiple nodes and making sure that we're not taking everything down. We were like putting a new ER or jar or whatever that we were putting back in the day. So zero downtime is something we chased for some time, and thanks to cloud native technologies, nowadays it's much more achievable. And Zero downtime that, for example, comes with Kubernetes is actually a good downtime, but a good zero downtime strategy, but it's a slow rollout. So this means that when you're going to use the default strategy from Kube, that one is going to be a slow one. That's why blue-green deployments or canary deployments are working better, because the rollout, although you need some more tweaks around it, is much more faster. However, and of course, scale to zero. I find it hard to believe that there are functionalities in distributed applications that are not used. However, let's assume that maybe you forgot about things. So if you forgot about things, scale to zero, yes, it's useful so that you will not use those resources unless they're needed. But the real concern that goes with scale to zero is like, how do you optimize the resource usage? It's not just scale to zero by itself.
And actually, one more thing, how do you actually optimize your startup? Well, how do you make sure that your cold starts are actually not that slow? Because when something goes down, it has to go up again. And if that is going down, it has to be, most likely it should be one way or another stateless, so you can actually get up. It can be scaled. It can be, created many instances of. And also, if it goes to zero, it has to start. If you create a super monstrous monolith that you shoved into a container and put on a Kubernetes cluster running on premise, how long time will it take to start? Will your user actually sit and wait for those 10 excruciatingly long seconds to actually get a response, right?
Zero downtime, we talked about the deployment strategies for Kubernetes, but graceful shutdown and fast startup, when we're talking about containerized apps, are really important when scaling up and down. Because if your application starts fast, when you are scaling up that application, that's going to be an impact on how the workload is, how fast your workload is going to be addressed. Now, the graceful shutdown, that's the other side of the story. When Kubernetes can downscale automatically. So when the automatic downscale kicks in, you don't want to wait a lot of time for your application to shut down and do a lot of stuff, because that's also consuming resources. You don't have the same workload as before when your application was under stress. So why use resources when you can be conservative with those resources and just improve your app? Then the size of the container image is the one that is affecting the quota that you have maybe for your registry. And also it can affect how much time it will take for Kubernetes to spin up another node if one of the nodes is failing, because that container image needs to be downloaded again. And of course, last but not least, customization of health probes. Just assuming that Kubernetes is gonna magically assess the health and it's gonna establish some default values, well, that works as well. But not being ready in time just because you went with the default, or not thinking on tailoring the health probes accordingly can impact that zero downtime strategy that you're thinking of. So please have in mind these when you're thinking about zero downtime. And of course, scale to zero. Well, we talked about do we really want to scale to zero, or do we really want to optimize the resources? If we are looking to optimize the resources, think about container resource limits and requests, CPU and memory specifically. Then size the container image accordingly. If you really want to scale to zero, Knative offers this kind of approach. You can scale to zero with Knative, and it's really cool, so you can go with that. But sometimes you can also reevaluate the auto-scaling conditions when it comes maybe you're, by mistake, spinning up too many pods when the workload, when the auto-scaling condition is it's too loose, I would say. Auto-scaling when, let's say, you're using only 30% of the CPU doesn't make sense.
You have to figure out what you use to measure. I mean, what is the bottleneck for your application? Is it memory? Is it CPU usage? Is it number of users? What is it? And actually create those metrics accordingly and create your scaling strategy based on those. Not just because standard is CPU usage, but maybe your app is memory intensive. Maybe your app is just going slow because you have more than 100,000 users, whatever. So that might depend, and keep in mind that those default metrics, they're good, but sometimes you need to reconsider those as well.
And those being said, thank you for listening to us.
Thank you.
And now we're waiting for questions from your side and more cloud-native concerns. We are gathering these kind of questions and
misunderstandings
from different folks around the world. So if you have more misunderstandings or more things that you've heard about and words that you don't know to put in context, we're welcoming those questions coming from you, and we can maybe share some examples.
Please share them with us, and hopefully, and maybe one of those or all of them will end up in a slide the next time we run this presentation again. Because we share the things that we have seen, we share the things that we've seen for our doing things for our customers, our clients, whoever that may be, our employers. Anything from your side, what you have experienced? Have you experienced people misunderstanding things? How did you react on that? Any thoughts, comments, questions? Anything goes. Anyone? Any hands? We've checked that your hands are working, so we know that. So use them now. No? Okay, there you go. One.
I see in general CPU and memory allocation people just randomly do it instead of really measuring how much that application really requires. It requires a lot of testing to really evaluate how much a particular part requires CPU and memory.
Yeah, so well, I'll try to repeat the thing. So I assume you're talking about scaling, and you're talking about that people just use a CPU as a measure, just they guess, right? They just say, oh, well, 2 CPUs and a little bit of memory and stuff.
So that they will not get any errors.
Yes.
Yes, so we're not playing a gambling game, like who's getting more or who's getting less. Well, less is a problem, because if you're assigning less resources, then your app is not going to behave correctly. It's going to continuously restart, and that's bad. But people tend to give more because they're we're nice as humans and
generous.
Generous. Thank you. That's the right word. We're generous humans, and sometimes when that's happening, we're also generous with the resources that we're using. One approach to that is probably you've correctly identified is load test, so that we can see the amount of resources that our app needs, and be sure that we're not using more than needed. So load testing on that case is working. I think in the era that we're living in, where much more pressure is coming over the applications that we're building, we have to not neglect load testing. I remember back in the day, this used not to be a concern, because, well, it's not that we didn't have that many users, but nowadays everything that's in our phones, that's in our browsers, it's close to user, so it has to be heard by many of us.
But that's a very good point. I mean, I totally agree. Do not guess, use metrics, measure, adjust, keep on doing all the time. Not until you're happy, because your application will develop, your new features will come. It will depend, or it will change the way it uses memory, CPU, whatever. And so you have to be, that should be like a continuous thing. Sure.
Other than CPU and memory, is there anything else we need to consider to increase the number of parts and decrease
So the question is if we need to think about anything else apart from CPU and memory to make sure that application is behaving, right?
Scaling policy.
Scaling, yes.
So the scaling policy, typically there are some custom metrics that you can use in Kubernetes. So the default one, the HPA, is very basic. But you can have your own custom metrics added to that. So in that case, you can enhance on that policy. And secondly, please try to avoid using HPA and VBA in the same time. Virtual pod autoscaling is also available, not by default. You have to install the virtual pod autoscaler. Thank God, because it comes with some benefits to use the virtual pod autoscaler, but you really have to pay attention not to have these kind of policies targeting the same deployment, so they get in conflict and you don't know what's going on there anymore. So I would say like adding custom metrics to what is already available in Cube, it would be great. And to my knowledge, there are ways, I mean, providers looked into this, and sometimes you kind of already get the enhanced way of working with those metrics, just getting the default. But yeah, when you look into the Cube specification, you see just the CPU, I think, min-max, and that's it.
Yep.
But there are ways to like enhance with your own custom metrics. Of course, you need to some stuff to be installed, but that's another story. Or maybe it's given by the provider itself, it's managed, and then you're again in a lucky situation.
But then again, it depends, right? It will you know your application better than anybody else, and you know where the shoe kind of is, where your foot does not fit the shoe, and where it's a bit like tight. And then you will know where you need to adjust to feel comfortable, right? And then maybe you need custom metrics, maybe you don't. But
most of the time, the custom metrics are also useful. So they're useful for the resource adjustment, but also it gives you a little bit more extra than the default ones.
Yeah, definitely. Thank you for good questions. Any other comments, questions, anything else? You feel more than welcome to, if you feel like doing that, ping us on offline as well, or online. I don't know how you call that. Offline of this conference, but online through Twitter and stuff. So feel free to do that as well. And if there are no more questions, we will say, oh, there's a hand. Yes?
Is it possible to see the very first slide where you define cloud native?
Okay, now we're going to get a lot of blinking. If you're light sensitive, you might want to look away. This?
The one that,
this one?
The one where we read the words.
Or this one?
try one more. Well, when I had a little graph chart.
Oh, you mean this? No. Okay.
Here.
Well, the graphic one. Yeah. So let me, do you mind if I take
No.
Of course. In case you wonder the drawings and that they're like looking weird, somebody, I'm not going to name any names, but somebody had like a very, very big attack of procrastination. So, ended up drawing them just in case you wondered.
So all these slides are available for us later, or
We can make them available. We can put them. It seems like it's going to be recorded, so it should be posted as well. But we can post it on Google Slides or just tweet the link or something like that. So I can do that. Just follow us on the social media, and then you'll see the link. So this is 2 of us there. Thank you very much for coming. Thank you for questions. Thank you for being here. Enjoy the rest of the conference.